Yay! I'm getting to go on a guided tour of Mars. This is so freaking cool.
You can see this spectacular panoramic landscape. This could be Canyonlands. This could be Death Valley.
What's the weather like in this section of Mars?
Yeah, the forecast for tomorrow is just like the forecast for yesterday in general. And like the forecast has been every day for billions of years. No chance of rain. Tonight's temperature is going to dip down to maybe minus 100 degrees Celsius, minus 200 change Fahrenheit. But tomorrow it's going to be a balmy, maybe +3 Celsius.
That's planetary scientist Jim Bell. He's taking me on the most unusual guided tour I've ever been on, along Mars's Gale crater, courtesy of images from the rover Curiosity. It's currently beaming back photos from the red planet. The view is gorgeous. The color of the landscape reminds me of Petra, the ancient site in Jordan, and its beautiful rose-colored sandstone. The sky looks like a silvery, very light blue, but that's thanks to the photo white balancing. It's almost as if we were standing on the surface.
Those beautiful pictures I was talking about that we've taken from rovers and landers that make it look like, oh, this would be a cool hike somewhere in the desert Southwest, right? Well, that's all wrong. I mean, you die in so many ways, so fast, if you're out there.
Not a tempting prospect. But that hasn't stopped humans for millennia from imagining themselves, or some other life form, as living on the red planet. NASA's next mission to Mars hopes to find out if life has ever been, or can be, possible there. It's January 2021, and as I record this, the latest rover, Perseverance, is heading to Mars. Those crunchy noises, they are the sounds recorded by a microphone aboard Perseverance, picking up the whir of the rover's thermal system as it hurtles through deep space at a speed of more than 50,000 miles per hour. This mic and Perseverance's sophisticated camera system are part of a suite of equipment that promises to reveal more about Mars' ancient past and present than any previous mission. I'm Amy Briggs, executive editor of National Geographic History magazine, and you're listening to Overheard, a show where we eavesdrop on the wild conversations we have at Nat Geo and follow them to the edges of our big, weird, beautiful world. This week, we hitch a ride aboard the Perseverance rover, sort of, and learn how its elaborate cameras are ready to get our closest ever look at the red rocks, craters, and canyons of an ancient delta on Mars. Its mission? To seek out signs of past life, collect samples for return to Earth on a future mission, and explore the Martian climate and surface to see if humans might one day make a trip to the red planet. Imagine we're in ancient Egypt, sometime during the reign of Queen Hatshepsut, roughly 3,500 years ago. The Egyptian astronomer Sennemut scans and studies the southern and northern skies and begins to painstakingly create a map. His map is one of the earliest pieces of evidence of our fascination with Mars. Thousands of years later, Mars's position in the night sky helped another scientist attempt to map the surface of Mars.
Sorry, our lights just flickered. I don't know if you saw that. What's happening here?
To find out how, I catch up with National Geographic contributor Nadia Drake. It's a bit tricky, though. We're in the middle of New York City's first snowstorm when I reached her. Nadia covers space, planetary science, astrophysics. As she says, everything that doesn't really happen on Earth. She also happens to be the daughter of renowned astronomer and astrophysicist Frank Drake.
There was one really influential map that was produced in 1877 by Giovanni Schiaparelli. And the reason why they were doing it at that time was because Mars was at opposition, meaning that it's directly opposite the sun in Earth's sky. So it's brightest and it's at its closest point in the two planets' orbits, and so they could see it the best.
But I needed to know, why were early astronomers so fascinated by a planet that they couldn't see all that well?
as one of the scientists I talked to said, it's just blank enough that we can populate it with our imaginings. It doesn't push back all that hard, even now.
My guess is Jim Bell appreciates the laxity. Oh, and it's time for a proper introduction. So for our listeners, please introduce yourself by saying your name and what you do.
Sure. My name is Jim Bell. I'm a professor in the School of Earth and Space Exploration at Arizona State University. And I'm a planetary scientist, kind of a mixture of an astronomer and a geologist.
To be clear, Jim Bell has lots more in his toolkit than the Egyptian astronomer Senemet, but his interest in space science was also sparked by looking at the sky.
I grew up in a relatively rural area that had nice dark skies, and my family got me a good telescope when I was 10 years old or something like that, and I'd schlep it outside and see stars and galaxies and the moon and the rings of Saturn, and it was just so cool.
Jim began digitally imaging the moon, Mars, and other planets while in grad school. He graduated just as NASA restarted its Mars exploration with the Pathfinder mission.
It was in the mid-90s and was the first rover on Mars, about the size, you can't see me on the podcast, but about the size of a laser printer or a microwave oven, a little rover called Sojourner. And that's how I got involved. The team needed folks with digital imaging experience. And I went from this, kind of fuzzy telescope view to right down on the surface, individual rocks and sand grains, it was like, wow, it was crazy. And I just got hooked.
Since then, Jim has been heavily involved in several NASA exploration missions to Mars, including with rovers Spirit, Opportunity, and Curiosity. He's now the principal investigator of Mastcam-Z, the main eyes aboard the Perseverance rover.
It's never a routine day to land something on another planet. We kind of take these things for granted because NASA's been so successful, but not all of them have been. And so, of course, you're biting your nails and when I watch them launch and when I watch them land, I've written about this. I describe it as wanting to dance and throw up at the same time. It's nerve-wracking.
That's quite a visual. It almost makes you wonder why anyone would sign up for this. But it seems Mars has this way of sucking people in, which gave way to a whole Life on Mars movement, Nadia explains.
There was the work of Percival Lowell, who was mapping it and was absolutely convinced that he was seeing this planet-spanning network of irrigation canals that were constructed by intelligent Martians. And those stories really took off. And so by the turn of the 20th century, if you thought that Mars was populated by intelligent aliens, there was a pretty good reason for thinking that. That's not crazy. Now, of course, we know that that's not the reality at all, because over the last 100 years, we've gotten a really good look at the planet's surface, and we know what it looks like.
More on that in a moment.
So the photography of Mars actually happened pretty early on, before 1910. And that was essentially what undid Lowell's theories, because people could see that the image of Mars taken through telescopes didn't match the maps.
It turns out it didn't match our imaginations either. Telescopes, then the first photos of Mars from space, courtesy of a flyby spacecraft, dashed all hopes of a planet teeming with little green men. In July 1965, NASA's Mariner 4 flew within some 6,000 miles of the Martian surface, snapping the first close-ups of the planet.
It returned photos of a landscape that looked cratered and dead, desolate, sterile. It looked like the moon.
It almost seemed as if those pictures cratered our interest in further Mars exploration. But something out of the clear blue sky reawakened that curiosity. I mean that quite literally.
scientists found what some of them believed was evidence for fossilized microbial life in a Martian meteorite that had been recovered in Antarctica and in the Allen Hills. So the meteorite is called ALH 84001, which I always feel really cool when I say that. It's like, I know it. And what happened was that they were looking at this Mars rock and saw this little wormy thing that looked like it could be a fossilized microbe. It looked like a life form.
It was 1996, and that discovery of microscopic fossilized bacteria found in a meteorite made its way into a major scientific paper, and then into headlines and into a speech by then-President Bill Clinton.
More than 4 billion years ago, this piece of rock was formed as a part of the original crust of Mars. After billions of years, it broke from the surface and began a 16 million year journey through space that would end here on Earth. I am determined that the American space program will put its full intellectual power and technological prowess behind the search for further evidence of life on Mars.
No matter that scientists questioned the findings, it's still debated in scientific circles and gave the Mars exploration program a second wind.
And so we started launching more spacecraft going to Mars to try and figure out once more if the planet was ever habitable by our standards. Did it have the things that we consider necessary for life to evolve and thrive? And if so, was it ever inhabited? And those are the questions that we're still really asking. We've kind of put the first one to bed. We know that Mars was habitable by our standards, but now the question is, did anything ever move in?
So I started this episode by talking about the Curiosity rover, which landed on Mars on August 6, 2012. It's still on the planet, surveying the Gale crater, analyzing drill samples, and tweeting the cutest selfies. Curiosity is kind of like the older sibling of Perseverance.
Perseverance is, in a lot of ways, like the Curiosity rover, and in other ways, very different. It's like Curiosity because it's built from about 90% spare parts from Curiosity. This is how NASA could afford it. You know, you don't just build one.
Hey, let's hear it for redundancy. That's wonderful.
Yes, yes. And so on the outside, it looks a lot like Curiosity. On the inside and in detail and in its mission, it's very different. Curiosity is exploring an ancient crater where from orbit we thought there might be signs of habitability on Mars in the past that tell us that Mars was a habitable world. And Perseverance will do something similar in another ancient environment, a crater called Jezero Crater that is it's not that big. It's sort of a Connecticut-sized crater. And but it has a beautiful river valley that flows into the floor of the crater with this spectacular delta, like at the end of the Mississippi River or the Mekong River. It's a beautiful delta. And it's all dried up now, of course. It's all ancient. It's been pockmarked with craters. But a long time ago, early in Mars history, it was warmer, it was wetter. There was a river flowing down this crater wall, depositing sediments in this much more Earth-like environment. And so that's where we're going to send Perseverance.
More on that mission in a moment.
Go Atlas.
Go Centaur.
Go Mars 2020.
8, 7, 6, 5, 4. Engine ignition 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
That was the launch of Perseverance on July 30th, 2020. It's the latest step after years of work by teams of scientists looking to answer the age-old question of whether life has ever existed on Mars. And while we count down to February 18th, the day Perseverance is scheduled to land on Mars, nothing is assured.
When I take a step back and I think about what this rover means, this rover is, all those late nights studying as a student. It's all of the late nights in the lab working with my coworkers, trying to figure out a problem.
Christina Hernandez has joined us now. She works at NASA's Jet Propulsion Laboratory in Southern California. She's been working on Perseverance, which she calls a one-ton robotic beast of a Martian explorer, as a payload systems engineer.
And what that means is I'm a jack of all trades. I get to work on the design, the build, the test, and eventually the operations of our 7 different instruments on the rover.
Christina has worked at JPL since 2013, but this is the first project of hers that's made it into space.
This rover is the sacrifices that my family and friends made, to allow me to work, 7 days a week, nearly 24/7, just to get the job done. And this rover, it's the faces of all my coworkers, all the people that I interacted with, the scientists, the engineers, and the business folks, the schedulers, just everybody who helped put this together. And when I think about the science objectives, it's surreal.
Perseverance's science objectives will be carried out by a suite of 7 instruments aboard the rover. We talked a little bit about Mastcam-Z, the main system that will image the planet with panoramic and stereoscopic cameras. There's a second camera, SuperCam, that can do chemical analysis in addition to imaging. Other high-level imaging systems aboard Perseverance include Pixel and Sherlock. Then there's Meta, a weather suite, RIMFAX, a ground-penetrating radar, and MOXIE, which can produce oxygen from carbon dioxide on Mars. Mind-boggling stuff. As a payload systems engineer, Christina focused her efforts on 3 of the 7 instruments, so it's best to let her explain how they work together.
The best example I could give is, say we've landed, right? We're on the Delta, and Mastcam-Z will take this beautiful panorama on the first few sols of Mars. And that's going to tell the scientists, we want to go left, we want to go right, we want to go straight. And all of the other instrument teams are going to be using that imagery to say, how does this correspond to the first science bits of information that I got down from the vehicle? Maybe Meta will say it was, a little bit windier than they expected. Sherlock has the Watson camera, and that Watson camera is kind of like Pixel and the other instruments close-up context camera, because it could kind of, if you think about that magnifying glass, it kind of get up close. And so it's really those first images that give you the kickstart of the science that you're going to be able to take at a particular location.
So it almost seems like there's an order of operations where, you have the camera, zooming around and being like, hey, there's a target. And then you have all the other little superpowers coming out and analyzing it before anybody makes a decision to go dig a hole or to, analyze.
Absolutely. I actually just got an image of Avengers Endgame with all the superheroes coming out, preparing for battle. That's really what it is, right?
Yep. I was thinking, I'm going to date myself. I was thinking of the Super Friends and the Hall of Justice, and they all hang out there, and depending on which villain attacks, that's who they send out.
I love it. I love it.
We'll have to wait for Perseverance to land to see what mind-blowing images it might beam back. But for the crew, the work continues, even while the rover is cruising through deep space. And Christina is preparing for her first experience as a Martian.
So our prime mission is 1 year on Mars, which is roughly, 2 Earth years. And what's really cool in this concept of, being a Martian, for the first few months, we'll actually be on this thing called Mars time. So we're going to align ourselves with the time zone that the rover's in. Eventually, we lose sync with, our Earthling friends. But, we become Martians for this, short period.
I had no idea yet that you're right. You're literally going to be experiencing Mars in the closest way possible.
I know some families, they, completely switch over together. And so that's something I'm going to talk to my husband about because we're working from home. I was like, do you want to go on Mars time with me? He might not be too happy about that, though.
Meanwhile, I want to get back to my own journey on Mars, thanks to Perseverance's predecessor, Curiosity. Back in a moment. So back to that tour. I'm with planetary scientist Jim Bell touring the Gale crater. The landscape, while barren, is breathtaking.
No vegetation, cloudless sky, spectacular hills slowly eroding away in the background, a couple of channels from where water once flowed long ago, flat plains with bedded, layered rocks that are we learned later, the ancient floor of a water-filled lake. This scene was a crater lake at one point in time, 3-4 billion years ago.
We're looking at Gale crater now. Where is that in relation to where Perseverance will be landing?
Yeah, Gale is not too close. It's just a little bit south of the equator, and Perseverance is going to be landing north of the equator, near a very famous feature to telescope observers through the history of telescopes, a large dark area called Syrtis Major. It's been seen since the 1600s in some of the first telescope drawings. So it was one of the first features ever seen on Mars.
I mentioned earlier that the color of the silvery blue sky was achieved with white balancing, but while I'm on this tour of Mars, I needed to know what it really looks like.
It's an artistic choice almost on how to portray these colors. There are versions of these kinds of panoramas in more natural Mars color, and the sky generally is pink. It's been described as pink. It's been described as salmon. It's been described as butterscotch. And it changes. It changes with time of day. It changes from day to day as dust storms come and go, just like Earth's sky. On Mars, there's always dust in the atmosphere. The atmosphere is so thin that if there were no dust, the sky would be black, like on the moon.
I'm curious, what would be your dream discovery from Perseverance? Like, shoot the moon, what is it?
The dinosaur femur? No. Nobody thinks that's going to happen. It's just the environment has been too hostile for macroscopic life like on Earth to be on that surface for long enough to evolve as it has on the Earth. The odds are stacked against us for that kind of thing on Mars. However, Mars doesn't care about the odds. Nature doesn't care about the odds. Nature freaks us out and surprises us all the time.
Back in a moment. Want to learn more about Mars? Check out our magazine story about the launch of the Perseverance rover and its science goals. Also, an explainer on the history of Mars exploration, an interactive about Mars's climate history and odds of habitability. That's all in the show notes, right there in your podcast app. Overheard at National Geographic is produced by Carla Wills, Brian Gutierrez, Jacob Pinter, Laura Sim, and Alana Strauss. Our senior editor is Eli Chen. Executive producer of audio is Devar Ardalan, who edited this episode. Our fact checkers are Michelle Harris, Robin Palmer, and Julie Beer. Our copy editor is Amy Kolzak. Sound design and original music for this episode was done by Ramteen Arablui, and Hansdale Sue composed our theme music. This podcast is a production of National Geographic Partners. Whitney Johnson is the director of visuals and immersive experiences. Susan Goldberg is National Geographic's editorial director. And I'm your host, Amy Briggs. Thanks for listening, and see y'all next time.